So I'm here at the workbench today with this N-Scale engine. This is a Model Power / MRC 440. This is one of those that came with TCC and sound installed when new. And I've always liked this engine. It's always worked really well until the other day when it started running erratically. A couple of things I noticed when it was running erratically. I was using an NCE power cab and watching the current on the screen, and the current was jumping pretty high and low, and the model was changing speeds from faster to slower, and the chuffs were getting out of time with the wheels. So I stopped and started doing some troubleshooting. My initial thought was that maybe the decoder was going bad. When I took the tender body off and tried to run the locomotive and watch the decoder, I felt that the decoder was getting very, very warm. So my initial thought was that it was a bad decoder, but before I bought a new decoder, I wanted to test the motor just to make sure. And what I found is that the motor itself was drawing far too much current. It was drawing about 250 milliamps at the most, and it would drop down to about 160 milliamps. That was all at no load, with the body. The motor fits inside the body with the body off the chassis. So I knew it wasn't like a bind in the chassis or something like that. And I went ahead and removed the motor just to have a look and see what the problem might be. What I ended up finding was a lot of carbon dust from the brushes. And I sort of suspected that maybe, the carbon dust was just causing issues with shorts or something, and just making the motor run erratically and draw too much current. So I used a little bit of alcohol spray I have. You could use any sort of electrical contact cleaner from the auto parts store or something. Sprayed it all out, and now I'm at the point where I need to put the brush holder back on. And I thought I would show you what I've done to allow me to do that. I don't know if you're able to see too well, but the brushes here are spring-loaded, and you can't push the motor onto the brush plate because the brushes will hit here on the motor. This is actually just a washer, and you probably can't see it, but the commutator here is also about the same size. And there's no way to put the brushes onto the commutator the way the motor is at the moment. And so I had to find a way to get this brush plate and the brushes back on the motor to test out my repair. What I ended up doing, again, you probably can't see, but I drilled two little holes, one right here and one right here, so that I could fit a thin brass wire here through the hole. I could push the brush out of the way, fit the wire through the hole to hold the brushes out of the way so that I could push the brushes and the cap back on the motor, and then pull the brass wire out and have the brushes seat back on the commutator. So let me assemble that, and I'll show you what that looks like real quick. So hopefully you can see this. This is what the motor looks like with the little wire tool inserted and assembled. So now all you have to do, hold the brush cap a little bit, grab some tweezers or pliers, pull the tool out, and the brushes should be seated. So I wanted to show one other thing real quick about this motor before I assembled it. If you actually run into this problem, you may not actually have to disassemble the motor to clean it out. If you look right here, there's one on this side, and if you turn it around, there's another on this side. These are two little mounting holes. They're probably threaded, so you could put a screw to hold the motor in from this end. Other than the holes I drilled on this side to allow me to do my little brush holder tool, there are no holes over here. But if you had, again, some alcohol in a spray can or contact cleaner with one of those red straws, you might actually be able to spray the cleaner in here and have it come out through the bottom. And that way you wouldn't have to disassemble the motor, and you could just take the motor out and do it that way. I don't think you could get to these holes with the motor in the body. You still have to remove it. But not having to take the back brush plate off makes things a whole lot easier. Just something to keep in mind if you should run into this problem. So we're going to do a quick test of the current draw. We're currently on a 250 milliamp scale. This meter is of course reading the voltage, so let's see what we get. There we go, we got 8 volts and running just a little over 50 milliamps. It's maybe 55 or 60 milliamps. I'm still comfortable with that, with the motor now on the chassis actually driving the drivetrain and the gearing. I'm not too worried about that. Just as a test, I wonder if we can adjust the load some. Yeah, and as we can see, it moves, current draw moves up as expected and goes back down as we release the load. So I think it's time to continue with the reassembly. So here we are, all assembled. I've got about an hour and a half of runtime on them. Things seem to be going well. I would like to point out a couple of assembly tips if you ever take one of these apart. The first one is the headlight contacts. There's a metal contact that drops down from the boiler and connects with one of the pickup contacts on this bottom plate. That was pretty difficult to get a proper connection made. It took a little bit of fiddling and adjusting of the contacts, but just trial and error, you'll eventually get it. The other thing I'd like to point out is it was a little difficult to get the tender body back on the chassis. The way I ended up doing it is probably quite similar to the way the factory did it. I put the decoder down first with the speaker wires coming out the back. I then put all those shrink tube splices on top of the decoder, and I pushed them out to the left and right sides of the tender body. That gave room for the speaker to set down close to the decoder. The other thing I found out is that if you replace any of those shrink tube splices, be very careful with the wires. They're very susceptible to heat, and I actually melted some of the insulation on those while replacing the shrink tubes. I had to make those repairs. The other tip I'd like to point out is actually an operational tip. I had a lot of problems with this locomotive and pulling power, especially going up grades. I think that exaggerates the problem. Typically what I would find is you would have problems where two pieces of track would come together and one rail might be higher than the other. What would happen is that this lead axle would end up being just a little bit above the rails in the air, and that's where the traction tire was. What I ended up doing, if you can see, is I moved the traction tire to the rear axle. In order to do that, I removed the bottom plate, took the rods off. They're held on by push pins that if you just pry them up, they'll pop off. And I just swapped the wheel sets. They're identical. They're both geared. As long as you get the crank pins set up in approximately the same position, if say this is 2 o'clock, they're both pointing to the 2 o'clock position, it'll go back together just fine. And that actually increased my pulling power going up grades. I can now pull about 4 pieces of rolling stock going up the grade, which is far better than not even being able to run the locomotive itself up the grade. Well, there it is. I think I'm going to call this repair a success. Hope somebody out there finds this video useful if they're attempting to repair one of these, or at least found it enjoyable. Thanks for watching. Have a great day.